On today's version of Ask a Scientist Anything, we're going to talk about why do we hear that matter is actually much more vacant than you think. You see your desktop, it looks solid, but some scientists will tell you that it's actually not as solid as you think. There's a lot of empty space in it. And that's because of how things are structured. So let's take a quick look at what that really means. Um, it because your desk is made up of these things called atoms, which are not they haven't been really understood nearly as long as you'd think they are. They were first theorized around 450 BC by this guy named Democritus, and then they were kind of forgotten about for a long time. And then around 1800, John Dalton really kind of proved they were there and gave us atomic theory, the atomic understanding we have today, or at least the start of it. So let's look at why things are more vacant than they are. This, what you see right here is a series of structures called carbon nanotubes, and these are just tubes made out of carbon. What you see on those big clumps, that's just dirt that wound up in there. But the little strings you see are really just tubes made up of carbon. And yeah, I know there's some blank spots in there, and there's some clumpiness, and that's not a solid material. But if you look at these little strings, those strings are molecules. They're very little, very long chain molecules. And this scale right here, this little bar at the bottom, that's 100 nanometers on the left. On the right, that's about a micrometer. So there's a difference in the size you're looking at by a factor of 10. Then let's go down and look a little more closely. So what do carbon nanotubes look like if you get really in closely? And what the heck is a carbon nanotube? Well, it's a tube, just like the inside of like a roll of paper towels or wrapping paper made out of carbon. It's just carbon. There's nothing else in there. They make them out of other things, but these are just carbon. But let's look closer. So some nanotubes are single wall tubes, some nanotubes are multi-wall tubes. This is a very close-in image of a multi-wall nanotube. So what you see is a tube inside a tube, inside a tube, inside a tube, inside a tube, and then an empty void in the middle, and then the other side of that tube. And if you look at these tube walls, they look a little fuzzy. Well, these tube walls are made up of atoms. And the atoms don't necessarily touch each other. In fact, they don't touch each other. They're separated by some distance, but they make up this wall, even though atom to atom, there's some space in between there. Let's drill in deeper. Well, here's a single wall tube. So you see these, this is not a tube inside a tube inside a tube. This is a single wall tube. So it's even smaller, but you still see that void and this wall of atoms, and that's because it has a molecular structure to it, just like the wood in your desk or the materials in your laptop. It's all made up of something. And that scale right there is around 10 nanometers. So we're getting down even smaller. And for point of reference, a hydrogen atom from electron cloud to electron cloud is about zero point 0.1 nanometers. So we're getting down to almost atomic size here. We're factor 100 off from atomic size, but it's getting pretty small. So you see that little structure right there on the top, that's 1.3 nanometers. That's getting little, right? But you can see the actual line of carbon atoms that make up the wall, which is kind of neat. And that's the molecular structure has that sort of thing to it where there's always going to be some blank space. Well, let's look at a diagram instead of a real one. So also, see these walls are separated by some distance inside the nanotubes. These things across the top are called buckyballs. They're sort of the building blocks of carbon nanotubes. And I actually met the two Nobel laureates, two of the three Nobel laureates that won the prize for the discovery of the buckyball. But on the bottom, their name were Bob Curl and Rick Smalley. They were down at Rice University. But if you look at the bottom, you've got the multi-wall and single wall tube structures. So you can see that yes, there's space in between the walls of the tube. There's an opening, and that's the way the molecule kind of looks. But also in between the individual atoms, you see these little bars. Well, those bars represent a molecular, an atomic bond that form the molecule. But the atoms don't ever really touch. They're separated by some distance. So that's what they mean when they say there's vacancies in there. Well, how deep does that go? Well, let's look inside the atom. The atom isn't solid either, right? You've got these electrons on the outside, you got these protons and neutrons on the inside, and there's all this empty space in between all that. But back up here, you see the atom drawn as a solid object, and in between the atoms there's space. Well, drive into the atom, and there's even space inside there. Well, what's this dense thing in the middle, right? It's made up of protons and neutrons. Well, is that solid? Well, it turns out no. The protons and neutrons are actually made up of up and down quarks, so there's actually particles inside there. So, the deeper you dig, the more you find out that this stuff isn't really as solid as you think it is. It feels solid to us because we're made up of molecules as well, and compared to us, it is very dense, right? So we kind of perceive it that way unless you look very closely. And that's what scientists are talking about when they say the matter you touch is really more empty space than you think. It doesn't mean you can walk through the wall. Okay, that just means that there's a lot of empty stuff there, and it's not as solid as it is. And why are carbon nanotubes important, you might ask? And that's one of the things that I actually worked on early in my career. It was part of my doctoral dissertation. Carbon nanotubes are very important little structures, but just a little tidbit on why they are lighter than aluminum and much, much, much stronger than steel. So, think about that. Very light material, very strong. Lots of practical uses for the things if you can figure out how to do it. And there's a lot of work that goes on with them to this day. So I hope everybody enjoyed this video. I hope that answers the question in a way that's understandable. Post more questions below. I'll keep doing as many videos as I can. And hope everybody has a great weekend, or whenever you're watching this video, have a great whatever day of the week it is. Today's Friday for me. But click like, subscribe, follow whatever platform you happen to see me on, and we'll talk to everybody next time.